So finally, we're going to look at volume of pyramids, spheres, and cones. And all of these formula are on your National 5 formula sheet, but it's still good to know how they work and where they come from. So first of all, we're going to look at the volume of a pyramid. A pyramid is a shape that has a base that then comes to a point above that base at a vertex. So instead of it being like a prism where you have a uniform base and that goes up as a uniform cross section all the way up the height of the shape, and you have that exact same area at the top of your shape, in a pyramid, that base, the vertices of the base are going to come to a point some height above the base. So the formula is V equals a third AH. So it's a third multiplied by the area of the base multiplied by the height of the shape. So basically what it's saying is that if we had a prism with that base that was the same at the bottom and the top, if we make a pyramid from it, we are going to be able to fit 3 pyramids inside the same volume as one prism. So you can see we've got a triangular based pyramid, we've got a square based pyramid, and we've got a pentagonal based pyramid. So sometimes you'll be given the area and then you can just substitute it in. Sometimes you'll have to use one of your area formula to calculate the area of the base, and then you can substitute it into your formula. And that's what we're going to have to do with this example here. We want to find the volume of this square-based pyramid. And so I've written the formula that we would be given on the formula sheet, V equals a third AH. Now, the area I have not been given, but it's the area of the base. And I'm being told in the question that my base is a square-based pyramid. So I know that in order to work out the area of a square, it's the length squared, which means it's going to be 50 squared, which means it's going to be 2,500 squared meters. The height is the height from the base to that vertex directly above it, or vertex. So that's going to be my h is going to be 21 meters. So then I'm going to substitute it into my formula, and I'm going to say V equals a third multiplied by 2,500 multiplied by 21. And that gives me a total volume of 12,500 cubic meters. Now I want to look at the volume of a cone. And for the volume of a cone, I'm working out the area of the base, and I'm substituting that in place of the V equals a third AH. And then this time I've got V equals a third pi r squared h, because I know that the area of a circle is pi r squared. So if I want to find the volume of this cone, the cone has a radius of 8 centimeters and it's got a height of 10 centimeters. So I need to work out by substituting into my equation. So my r is 8 and my height is 10. So V equals a third multiplied by pi multiplied by 8 squared multiplied by 10. And that gives me a value of 670.2 cubic centimeters. So what about the volume of a sphere? Well, the volume of a sphere formula is V equals 4/3 pi r cubed. And it's really important that you remember to write the fraction the correct way round. So it's 4/3, so it's 4/3 multiplied by pi multiplied by r cubed, remembering that r cubed is r times r times r, not r times 3. So we want to calculate the volume of a football with a diameter of 22 centimeters. And we want to give our answer to 3 significant figures. So I'm going to draw a sketch of my sphere. And I've been told that the diameter, so going from one side to the other side of my football, is 22 centimeters. Now you can see in my formula, I want r. So I'm going to have to half my diameter to get an R of 11 centimeters. And then I'm going to put it into my formula. So V is going to equal 4/3 multiplied by pi multiplied by 11 cubed. And that gives me a total value of 5,575 and some change. Remember, if I'm being asked to round to 3 significant figures, I need at least 4 significant figures in my unrounded answer. Then I'm going to work out which number I'm looking at rounding to. So my first significant figure is the 5, my second significant figure is the next 5, and my third significant figure is that 7. So therefore it means that I'm using the 5 afterwards to decide what I'm going to round the 7 to. 5 or more means I'm going to round up. So I'm going to round to 5580, so 5,580, and it's cubic centimeters for my unit. So my final example is going back and looking at the cone that I had in one of our previous examples, and this time we've kind of made it into an ice cream cone, and we've added a hemisphere or half of a sphere onto the top. So I brought that information about the volume of the cone part from the previous example, which is 670.2 centimeters cubed or cubic centimeters, and I want to work out what the hemisphere is going to be. And a hemisphere is half of a sphere. So we know that the volume of a sphere from our formula sheet is 4/3 pi r cubed. And this time we've been given r, so we don't need to do any extra calculations in order to determine what that is. But we know that it's a hemisphere, so we know that we need to divide that by 2 to get half of a sphere. So now we're just going to substitute our information in. So V is going to be 4/3 multiplied by pi multiplied by 8 cubed, and then we're going to divide that by 2. Now, remembering that the question's asking us to round 2 significant figures, I want to make sure that I've got at least 2 significant figures in my, or 3 significant figures in my answer. So I'm going to get 1,072.3 and some change, and that's cubic centimeters. So the total volume, so my V total, is going to be the volume of the cone, which was 670.2, and now I'm going to add on the volume of my hemisphere, which is 1,072.3, and that adds together to give me 1,742.5 cubic centimeters. Now it's asking me to round to 2 significant figures. So my first significant figure is the 1, and my second significant figure is the 7. And so I'm using that 4 to decide what I'm going to round to. So 5 or more means I would round up. So I'm going to leave the 7 alone. And so my answer is going to be 1,700 cubic centimeters for the total volume of this shape, which was constructed from a cone and a hemisphere.